Hello again. Today we're going to talk about graphing rational functions. So I wrote a few rules for you here. You really need to know these rules about the graphing rational functions. So basically the first one is vertical asymptotes. It's an asymptote is a vertical dotted line that you get very close to, but you never touch. And we just draw it there in the real graph. It's not really there, but we draw it there so we could know where we're getting close to and we're never touching and so on. So how do you find out if you have a vertical asymptote? Basically, you look at your equation and then it's the x value that makes the denominator 0. So if we're looking at this as an example, it will be 4. Horizontal asymptotes, you have 3 different situations. You have the degree on top is less than the degree on the bottom. So if you look here, the degree on top is 0, but the degree on the bottom is 1. So if that's the case, then y equals 0 is your horizontal asymptote. Another scenario, when the degree on top is greater than the bottom, then there's no horizontal asymptote. However, you'll have oblique asymptote, and we'll talk about that later. And then if the degree on top is equals to the degree on the bottom, then it's the coefficient of the top over the coefficient of the bottom. And that's basically the coefficients besides the highest degree on top and bottom. And finally, we will talk about discontinuity, which you have a hole in the graph. That's when the numerator reduces with the denominator. And once we have an example, I'll show you how that works. So we're gonna look at this question first. So let's see if we have a vertical asymptotes. And as I said, this is the x value that makes the bottom 0, and x equals 4 will make the bottom 0 here. So that's your vertical asymptote. Horizontal asymptote, it's y equals 0. And as I said, if the degree on top is less than the degree on the bottom, because the degree here is 0, because you don't have an x, and here the degree is 1, so the top is less than the bottom, and therefore y equals 0 is your horizontal asymptote. So if I'm going to graph this, the first thing is I draw my dotted line as vertical asymptote. And then I'm just going to use a different color here for my horizontal, because it's right on the x-axis, y equals 0, so I'm just going to dot right inside there. So this is what it is. Then it's sometimes good to do a table of values. So here, all you need to do for a table of values, x, y, is find out what's happening on this side of the vertical asymptote and on this side of the vertical asymptote. So let's say if I plug in 3, which is on the left side of the vertical asymptote, and then I'll plug in 5, which is on the other side of the, or the right side of the vertical asymptote. So if I plug in 3, that's 3 minus 4 is negative 1, 2 divided by negative 1 is negative 2. And if I plug in 5, 5 minus 4 is 1, 2 divided by 1 is 2. So I have a point at negative 3, at 3 and negative 2. And I have another point at 5 and 2. If you want to find what the y-intercept is, just make the x 0. So if you make x 0, you get y to be negative 1/2. So 0 minus 4 is negative 4, 2 divided by negative 4 is negative 1/2. So you could add another point right here, add 0 and negative 1/2. And knowing this point here, and knowing that we have a vertical asymptote and horizontal asymptote that I'm gonna get very close to but never touch, then I know my graph is just doing this on this side, and here just gonna get close to the x-axis side. You don't even need another point here. You could just say, I'm gonna get very close to the x-axis right here, and I'm gonna get very close to the vertical asymptote right there. So this is basically how you graph this kind of graph. I'm just going to erase this one and then go to the next example. Yeah. So the next one I'm going to do is y equals x squared plus 4 over x squared minus 4. So always when you have quadratic function on top, quadratic function on the bottom, you need to factor when you can. So the top definitely doesn't factor, but the bottom will factor. And we have still x squared plus 4 on top. So makes it easier for me now to see what the vertical asymptotes are. And it's going to be x equals plus or minus 2 because negative 2 will make this 0. And x equals 2 will make this 0. So that's why we have vertical asymptotes right there. Also, my horizontal asymptote, since the degree here is the same and the degree here is the same as the coefficient on top over the coefficient on the bottom. So that's 1 over 1, which is y equals 1 as your horizontal asymptote. Now, I'm just going to plot everything I know so far. So we have x-axis, y-axis. Then I'm just going to do a few scales there. Yeah, so now my vertical asymptotes are at x equals 2. So we're gonna have a vertical dotted line this way. Also at negative 2, so I'm gonna have another vertical line that way. And I'm gonna do table of values now. But before that, sorry, also the horizontal asymptote is at y equals 1. So I'm just gonna put that as well, right there. Now, I'm gonna choose one x value on the left side of the vertical asymptote, so negative 3. Also, on the right side, I'm gonna use maybe 3, negative 1, 0, and 1, negative 2, negative 1, 0, and 1. And then on this side of the right side of the asymptote, I'm gonna use 3. Now I'm gonna take these numbers and plug them right here. So that is negative 3 squared is 9, plus 4 is 13. And then the bottom is 9, minus 4 is 5. So 13 divided by 5 equals, 13 divided by 5 equals 2.6. So this is 2.6, and be assured this is 2.6 as well, because negative 3 and 3, when you square them, they're both positive, so they give you the same answer. I'm gonna put in negative 1, so that's 1 plus 4 is 5, and this is 1 minus 4 is negative 3, so 5 over negative 3, just negative 1.7. If I put in 0, I'm gonna get negative 1. And if I put 1, I'm gonna get the same thing as when I plug in negative 1, so negative 1.7. These points are enough to basically graph all of this. So let's plot them. Negative 3 and negative 2.7. Oops, sorry, negative 3 and 2.6. Negative 1 and negative 1.7. So somewhere around here, it's not going to be very accurate. 0 and negative 1. I'm just going to use different color for my points so we can see them. And then negative 1 and negative 1.7, so around here. and then 3 and 2.6. So 3 and 2.6, which is somewhere around here. Now, having these points in here, it tells you you're going to get you connect the points and you're going to get very close to the vertical asymptote, never touch it. Yeah. These points here will indicate that I have this right here, because you have a horizontal asymptote and a vertical asymptote. From this point, going this way, you're going to get close to the horizontal asymptote, and going this way, you're going to get close to the vertical asymptote. And the same thing here, you're going to get very close to the vertical asymptote this way, and you're going to get close to the horizontal asymptote this way. So these few points are efficient enough to graph this with confidence. Okay, so I'm gonna delete this and I'm gonna do the last one. And the last graph will be a graph with a hole. I'm not gonna do oblique asymptote today, but hopefully I'll touch on that next time I post a video. So we have y equals x squared minus 16 over x minus 4. And this one here, definitely you always have to factor before you do anything, always factor. So y equals x minus 4, x plus 4 over x minus 4. So now it's this discontinuity, hole in the graph. If the numerator reduces with the denominator, so as you see, x minus 4 is going to reduce with x minus 4, which ends up giving me y equals x plus 4. And then we know we have a hole of 4 because 4 is a discontinuity. That makes the bottom 0. It's not a vertical asymptote just because it's canceled with the top here, but it will give you a hole in the graph. So it'd be 4, and then you plug in the 4 into this equation, the simplified form of this, to get where the hole is exactly as, or the coordinate of the hole. So it will give you 8. So this is a lot easier to graph because all you need to do is just 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we know the hole is at 4 and 8. So 4 and 8, just around there. From going back to graphing linear equations, y equals x plus 4 is a linear equation that gives you a straight line. The y-intercept here is 4. So there's another point. If you know this, 2 points here, you know the hole and you know this point, these are enough points to give you a very accurate graph, which is a straight line with a hole right in the middle. So oops. So 4 and 8, which is, wow, sorry about that, just here's my eraser. Okay, so we know 0 and 4 is my y-intercept, 4 and 8 is where the hole is, and I'm just gonna graph a straight line that is there. So it's not the best straight line, but this is what you get from all of this. Basically, it's a linear equation with a hole in the graph. And that's it. Next time we'll go over oblique asymptotes, and maybe we'll explore something that doesn't have any vertical asymptotes or a hole, and it doesn't have oblique asymptote either. So till next time, take care and stay safe. We'll see you soon. Bye-bye.